Hello student, today we will be solving the IB Math AHL May 2025 paper 2 Tension 1 question number 11. You will be getting the solutions for the first 10 questions from this paper and the solutions for the other questions from the other past papers in form of playlists on my channel NS Online Math Tutoring classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I'm an online IB Math AHL level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve the question number 11. The maximum mark is 19. In a marathon race, the random variable t represents the time in hours taken for a runner to complete the race. No runner completes the race in less than 2.25 hours and no runner completes the race. It completes it in more than 7.5 hours. The probability density function for T is modeled by F, which is defined by F of T is 4 over 21 times 1 minus cos of 4 pi over 9 times T minus 2.25. This expression is valid for T values greater than or equal to 2.25 but is less than 4.5. And f of t is equal to 4 over 21 times 1 plus cos. This was 1 minus and this is 1 plus cos pi over 3 times t minus 4.5. For t values between 4.5, that is t is greater than or equal to 4.5 but is less than or equal to 7.5. And f of t is equal to 0 for other values of t. The graph of f has a maximum point at t equal to 4.5 hours. Shown in the following diagram, this is the diagram that they have given. Subpart E is having 3 further subparts. The subpart I is saying, find the value of the integral of f of t with respect to t and the limits of integration will be 2.25 to 4.5. And this is a paper 2 question, so you can use your calculator to find the answer. So, AI, and it is between 2.25 to 4.5. So I have to take this expression of f of t. Okay. So 2.25 and 4.5. I can keep the 4 over 21 outside. So it is 4 over 21 and 1 minus cos 4 pi over 9 t minus 2.25. Okay, and dt. Okay, so this will be equal to, we need the calculator. This is a calculator and it is 4 over 21. Let me keep it outside the integral sign. 4 over 21 times the integral of, so I am taking this is the integral sign and the limits of integration will be 2.25. Upper limit is 4.5 and this one is 1 minus cos 4 pi over 9. So 4 times pi over 9 times t minus 2.25. Okay, and that's it, and dt. There should be another bracket. Okay, 1, 2, 3, and anyway, it is dt. Enter. 0.42857. So correct to three significant figures, it will be 0.429. Okay. This is 0.429. Correct to three significant figures. Okay. So, but I write down the mode of t. The mode of t will be the t value for which the function value is the maximum. And they have said the graph of f has a maximum point at t equal to 4.5 hours. And we are seeing from the graph at t equal to 4.5 hours, the graph is having the maximum value. So, this will be the mode. I mode of t is equal to 4.5 hours. Okay. I determine which is greater, the mode of t or the median of t, justifying your answer. This is carrying, the subpart A is carrying 4 marks. So this will be carrying 1 mark, this will be carrying 1 mark, and this will be carrying 2 marks, because 1 mark for whether it is greater, which one is greater, mode or the median, and the second mark is for the justification. Okay. So okay, so we have seen that the mode is 4.5, and up to 4.5 we are seeing the integral. This will be the probability. This is 0.429, which is less than 0.5. The median will be half. The probability will be half at the median value. So therefore, because this is 0.429, which is less than 0.5, so the median has to be more than 4.5. Okay. So because 2.25 to 4.5, f of t dt is equal to 0.429, which is less than 0.5. Therefore, median of t will be more than 4.5 hours. So, therefore, median of t will be greater than the mode of t. Okay. So the runners who finish the race in 3.5 hours or less are considered to be fast runners. Subpart B's question is find the probability that a runner chosen at random is a fast runner. That means the t value should be less than or equal to 3.5 hours. Okay. So subpart B, P of t less than or equal to 3.5 is equal to 4/21. We have to take this this expression because it should be less than or equal to 3.5. So 4 over 21 and integral of 2.25 to 3.5 and 1 minus cos 4 pi over 9 t minus 2.25 dt. So this is equal to, again we have to use the calculator. Okay, so 4 over 21 again. Times integral of 2.25 is the lower limit, upper limit is 3.5, and the integrand 1 minus cos of 4 pi over 9 times t minus 2.25, and this is dt. Okay, it is 0.1037492. I'm taking because I'll be needing this if when we come to the part C, you will be seeing I'll be needing this value. So first of all, let me write the answer correct, not correct to three significant figures. I'm taking 0.1037492. Okay, 0.1037492. 0.1037492. So which is equal to 0.104 correct to three significant figures. So support C, find the probability that a fast runner, that means that runner is taking time less than or equal to 3.5 hours, chosen at random, finishes the race in 3 hours or less. So given that the runner is a fast runner, so it is a case of a conditional probability. Okay, so it is P given that, so T is less than or equal to 3, given that T is less than or equal to 3.5. Okay, so this is equal to, the numerator should be T is less than or equal to 3 intersection T is less than or equal to 3.5. What is less than or equal to 3 has to be less than or equal to 3.5. Okay, so therefore the numerator is P of T less than or equal to 3, and the denominator is P of T less than or equal to 3.5. Over here, I will be needing this value. So that is why I have written more number of digits for this answer. And then, of course, you have to give the final answer correct to three significant figures. Okay. So now, first of all, I have to get the value of this P of T less than or equal to 3. So let's see. Let me just try to copy paste. And the only thing that will be getting changed is this one. Yeah, It is 2.25 to 3. This is the only part that will be changing. Every other part is the same. The expression is the same. So I come over here and this is this. Okay. So I can now I have to compute this conditional probability and it is the answer for the numerator, and for the denominator, let me go to the this one. It is control C and I come over here, control V. See, I've got this one 1037 0.1037 and all. Okay, so now enter. So it is 0.238. Now I'll be writing the final answer, so I can take the answer correct to three significant figures. It will be 0.238. Okay, so this is equal to 0.238 correct to three significant figures. It is carrying 3 marks. So if you want, you can give the value t of p of t less than or equal to 3. What was it? It is 0.024715. Let me take 0.024715. 0.024715 divided by, and taking this one, 0.1037492. So this is equal to 0.238 correct to three significant figures. Okay. So part D, find the lower quartile of T. So lower quartile of T, and which expression should we be taking? We have seen up to 4.5, the probability is 0.429. So for the lower quartile, the probability will be 0.25. Therefore, we have to take this expression. Okay. So it will be, let the lower quartile be secure. So therefore, 2.25 to Q f of t dt should be equal to 0.25. Okay. And these were the expressions of f of t. So therefore, 2.25 to Q, and I can write the 4/21 outside, and it is 1 minus cos 4 pi over 9 t minus 2.25 dt is equal to 0.25. Okay, and we have to solve for Q, so we will be using the nsolve. So menu and algebra number 3 and number 1 is numerical solve. Okay, and it is 4/21 times the integral, lower bound is 2.25, upper bound is Q, and the expression is, okay, let me just again copy paste. Yeah, so this is C, Okay, and this will be Q. And okay, fine. dt equal to 0.25. And then we have to declare the variable. So it is comma and then Q. And enter. Okay, it is 4.0129. So correct to three significant figures, it will be 4.01. Okay, using nsomtc, GDC nsomtc, the lower quartile is equal to 4.01 hours. Okay, correct to three significant figures. Each runner's time is converted to a score which is calculated as A minus BT, where T represents the time in hours and E and B are greater than 0. They are positive numbers. Consider the random variable P, which represents the score of a runner. It is given that expected value of P is equal to 100 and the maximum possible score is, that is P max is 150. So part E's question is use E of T, the expected value of T, as 4.723 to determine the value of A and the value of B, giving your answers to the nearest integer. This is important. Okay, it is carrying 5 marks. Okay, so I'm writing over here. I cannot move down further because I have to see this part also. So P is equal to A minus BT and P max is equal to 150 and expected value of P is equal to 100. Okay, these are the things that, okay, now I can scroll. Okay, so E of T, we have to find the values of A and B, two variables. So we need two equations. Okay, so P max is 150. So I can write 150 in place of P equal to A minus B, and what will be the time value? See, which runner will be having the maximum score? The runner who will be winning the competition, winning the race, that runner will be having the maximum score. And what will be the runner's time? The runner's time will be the minimum time, the least time that was taken for all runners. The minimum time that was taken will be the time taken by the winner of the race. Okay, so that will be the time which corresponds to the minimum value of T, will be the time for the winner, and that winner will be getting the maximum score. Okay, so this T value should be the minimum value. And what is the minimum value? It is 2.25. Okay, so one of the equations is 150 equal to A minus 2.25B. So this can be written as A minus 2.25B equal to 150. This is one of the equations, and we need another equation. Okay, and this will be using this one, expected value of P. This, in place of P, we can write this. It is the expected value of A minus BT. Okay. And what will this be equal to? It will be equal to A minus B times expected value of t. Okay. So this should be equal to 100. Therefore, A minus what was the expected value of t given? E of t is equal to 4.723. E of t is 4.723. Okay. So A minus 4.723 B is equal to 100. This is the second equation. Now we have to solve these two. So calculator and menu and then algebra number 3 and then solve system of linear equations, that is number 2. Number of equations, it is 2, and the variables you can keep them as, sorry, this is 2 and you can keep the variables as x and y. You can change these two variables to x and y, or else you can change the variables to a and b as well. So a comma b. Okay. See, the variables have been taken as a and b, and we will be entering the two equations. The first equation is a minus 2.25b is equal to 150. So it is a minus 2.25b is equal to 150, and the second one is a minus 4.723b equal to 100. Okay. Well, we have got the two values of a and b. So 195.49 I'm taken. So a is equal to 195.49 and b is equal to 20.21. Okay. 20.21. So therefore, A is equal to 195 and B is equal to 20. Correct to nearest integer. So now we come to the last part of this question. Part F, given also that the variance of T is 0.906, find the variance of P. Okay. So it is carrying just 2 marks. Variance of T is given as 0.906. Variance of T is given as 0.906. We are asked to find the variance of P. Variance of P should be equal to variance of A minus BT. So this should be equal to B square times variance of T. These are given in your formula booklet. Okay. So, and variance of T, that is, you can write this as, sorry, in place of B, I have to write its value. So I'm taking 20.21 whole square, and variance of T, which is equal to 20.21 whole square and 0.906. Okay. So let's see what is the value. 20.21 times 906. Okay. Correct to three significant figures, it is 370. Okay. Therefore, variance of P equal to 370 correct to three significant figures. Okay. So we have completed answering this question number 11. Thank you for staying with me till the end. Please like this video in case you have liked my explanation, and please do share and subscribe to my channel. Your liking, sharing and subscribing will be really helping me. It will be motivating me. It will be increasing my videos reach. So please do like, share and subscribe. And we meet again very soon in our next session. We'll be solving question number 12 of the same paper. Till then, bye.